So the next one, again, it's an idea we've seen, is the adding and subtracting of the ordinates. Remember, ordinates is another name for y values. Right? So if we want to draw a function x plus g of x, then the idea is we graph the two individual graphs, and then we simply add their y values. Or with a ruler, we just measure them and go, oh, I'll add 1 centimetre to that, I'll add 2 millimetres to that, and so on. So x plus 1 on x. There's y equals x, and there's, I think, a quite nicer y equals 1 on x. Freehand, that's not bad. Okay. So how I would approach it, I'm going to find key points. So if there's anywhere where the function equals 0, that's obviously an easy point to work with because I'm adding 0 to the other graph. However, in this case, I can't do it because in one of the graphs, we have a discontinuity. And so any discontinuity is going to remain. Because if I can't sub it into one of the functions, then I can't sub it into this new function where the two things are added together. So it will still be a vertical asymptote there. Vertices, turning points, points of intersection, they're all good key points. Points of intersection are nice and easy because I know I just got to double that value and then I can add it on. So let's say, there we go. I thought that'd be the first one I did. And there's another one. Now, you just do as many as you need to, really, to get a feel for what the curve's doing. And you can see what's happening here. As this curve, the hyperbola, is getting closer and closer to x value a y value of 0, then we're adding less and less on. So now we're getting closer and closer to y equals x. So I guess it's another reason why y equals x ends up being the asymptote. Because we're adding that asymptote of 0 to the y equals x there. There it is. Ooh, what a lovely little graph that is. Things to keep in mind. As I was saying, discontinuities, they're going to remain. So any exclusions in the domain of one of the original functions will become a discontinuity in the new function. So x plus 1 on x, or 1 minus 1 on x. If I was going to add those together, here's the interesting thing. You'd think you're just drawing y equals x plus 1, but you're not. Because the original graphs that you added together had discontinuities at x equals 0. So it's the difference between, if they asked me to draw y equals x plus 1, fine, I'll draw a straight line, y equals x plus 1. But if they're asking me to draw y equals function x plus g of x, then I'd have to draw something like that, where I put a point discontinuity in at 0. So a really subtle little difference, and people miss out a lot on that one because they think, oh, I'll just add them together. X plus 1, nice and easy, just draw it. Okay, x-intercepts. If function x is equal to negative g of x, this is where we find the x-intercepts. So they're symmetric about the x-axis, basically, is what I'm saying. So if we find the point where the same distance above and below, then we know when we add them together, we'd have to get 0. And sometimes I do that on mine if I'm not sure, is I'll actually get a ruler and just slide it along the x-axis until the distance above and below is the same, and then I know, oh, righto, that's where the x-intercept's going to be. Symmetry, like functions retain symmetry when added. So in other words, if the two things when you add together are both even functions, then when you add them together, the new thing will be an even function. And if the two things when you add them together are odd functions, yes, the two things individually are odd functions, when you add them together, they'll still be an odd function. There you go. So odd plus odd will be odd, even plus even will be even. Odd plus even will just be a mess. Oh, these ones, absolute value plus absolute value. I like to break it up into the critical points, what's happening at those critical points. And the critical points are the absolute value signs when that's going to be 0, because that's when it's going to change from positive to negative. So the first thing would be when x is less than negative 3 would be a key point. So if x is negative 3, then what I say to myself is, x plus 3 would be a negative number. So therefore, what I would have would be the negative of x plus 3 when I go the absolute value. Whereas 1 minus x, let's have a look at that one. If I was to put some number smaller than negative 3 into that, I'm going to get a positive number. So that will remain positive. So I know I'm going to draw y equals minus 2x minus 2 on the left-hand side of negative 3. In between minus 3 and 1 then would be now the thing to look at. Well, x plus 3 will just be x plus 3, because again, subbing a number that's in between 1 and minus 3, so let's say 0. We get 3, which is positive, so it stays the same. The other one, that stays the same as well, doesn't it? So in between, we just get a constant value of 4. And greater than or equal to 1, the first one's going to be positive. The second one is going to be negative now, isn't it? Because 1 minus a number bigger than 1. So it'll become minus 1 minus x. We end up with 2x plus 2. So let's draw those in. There's the first section, less than negative 3. Then we get a constant value of 4. And then it's off doing the other one there. Well, that's plus if I'm adding the two. Subtraction is exactly the same, because really addition is subtraction. Subtraction is addition, because we know about negative numbers. So you can think of subtraction as adding a negative number. So we do exactly the same idea. So actually what I tend to draw is, instead of drawing the graph of, say, y equals g of x, I'll draw the graph of y equals minus g of x, and then just add the two graphs together. So x minus sine x. Okay, anyway, y equals x, there's the y equals x, there's y equals minus sine x. This time I've got a stack of x-intercepts. So each one of the x-intercepts on the blue curve will be just the same point on the red curve, because I'm adding 0. So the y value won't change. And the other key points, I've got a stack of maximum and minimum points on that sine curve as well. So there's a whole heap of points that I can choose. There's those x-intercepts. Now, unfortunately, because of the scale of it, I can really only do a couple of those turning points, because this second one here goes up the top. What ends up happening is it looks like it's not actually a sine curve, but you get that winding feature around y equals x. But as you can see, it's not like that's symmetric between those 2 points there. So it's not actually a sine curve. Okay, so 8b has got some questions there on this sort of idea.